value multiplied by its probability. So the first one's going to be 0 times 0.133. Next one is 1 times 0.382. Next one is 2 times 0.367. And the last one is 3 times 0.118. So then you'll end up with 0 plus 0.382 plus 0.734 plus 0.354. And you end up getting, what do you get in the end? 1.47? Great. Yep. And then your mean is exactly the same as your expected value. They're the same thing. 1.47.
We literally just debated that.
Yep. That's good. Yeah. So now you won't forget it, right? Yeah. Okay. Somebody from a previous class brought up the part about, well, what's up with this 0.49 thing, right? Someone see that? The probability of a girl having a girl is 0.49 for a particular family. And where it comes in is, we're having 3 children. What's the probability that out of those 3 children, all of them are girls? So that means girl, girl, girl. What's probably the first one's a girl? 0.49. Second one's a girl? Third one's a girl? 0.49. So girl and girl and girl and we multiply. So 0.49 times 0.49 times 0.49, you will get 0.118 if you multiply those. Probably you get no girls. What's probably that the first kid is not a girl? 0.51. Second one, 0.51. Third one, 0.51. Not a girl and not a girl and not a girl and we multiply. So 0.51 to the third power, that's where you get 0.133. This one is a little bit harder because exactly one girl, that means girl, boy, boy, or boy, girl, boy, or boy, boy, girl. There's 3 different ways of doing that. So you have to find the probabilities of each of those and add them up, and you'll get this. This one, 2 girls, that means it could be girl, girl, boy, girl, boy, girl, or boy, girl, girl. You have to find all those 3 probabilities, add them up, and you'll get this. So that's where these come from. Yeah?
How'd you get the 0.51 for the no girls? This one?
Because if probably of it being a girl is 49%, the probability of it not being a girl is 51%.
Ah, yep.
Yeah. Yeah. Good questions. Thanks. Good? Okay. Awesome. Now we're going to go out of order. Go to your chapter 5 notes. Go to page 3. And towards the top, towards the middle, kind of between the middle and the top, about a third of the way down. That's where we are right here, towards the top. Page 3. Oh, I'm sorry. I'm so sorry. Good question. Keep wanting to skip this one. What's the probability you have 3 girls? Yep. So is that unusual?
No.
What's our guideline for unusual?
5% or less.
5% or less. This is not unusual. Unusual. It's more than 5%. Right? This is 11.8%. Totally more than 5%. Good? Thanks for bringing that up. I didn't mean to skip that. Okay. Now, chapter 5 notes. You guys have your chapter 5 notes out? Turn to page 3. We're going to skip ahead a little bit. We're going to come back. We're going to jump around a little bit. So towards the top, the blank or expectation of a discrete random variable is the blank of the probability distribution. Fill those blanks in from those words up there on the screen. Fill that in. Fill it in. Chapter 5 notes. Page 3. 5 notes. Okay. Okay, so here we have our, again, our expected value is the same as the mean. How do you find that? You take every x value, multiply by its probability, and then you add them up.
And you add them
Yep. So here is an example. Say we had, why am I reading? Sterling, read.
You have 6 balls, numbered 1 to 8, and 13 are placed in a box. A ball is selected at random, and its number is recorded, and it is replaced. Find the expected value of the number that will occur.
Good. So what do? You have all these balls in there. There's 6 of them, numbered 1, 2, 3, 5, 8, and 13, all with 1/6 probability. So you take each one of those numbers, multiply by its probability. If you add them up, you'll get 5 1/3. That means if you drew a bunch of balls over and over and over again, thousands of times, and you average what you got, you're going to get really close to 5.333. You do it thousands of times. That's what you're going to get on average. So what I want you guys to do is take a look at this problem here and try to figure out, let's get a reader for this one actually. Andre, go ahead.
Life insurance. A 35-year-old woman purchases a $100,000 term life insurance policy for an annual payment of $360. Based on a period of life table for the U.S. government, the probability that she will survive a year is 0.999057. Find the expected value of the policy for the insurance company.
Great. So, who has ever heard of life insurance? Good, a lot of you. So my next question is, if you haven't heard of it, who's ever heard of a murder mystery where the wife kills her husband for the insurance money? Right? Right, so what does that mean? It means that he has some insurance policy out. If he dies, then his beneficiary will get that amount of money. If he has $1 million life insurance, if he dies, then she'll get $1 million, unless she gets arrested for murder. So, who pays for this $1 million? The insurance company. It's not just, God just doesn't say, boom, you get $1 million. The insurance company pays for that money. It's out of their pocket. So, you got to figure out the expected value of the policy for the insurance company from their perspective. So you need to make a little thing here of x's and the probability of x, and figure out what are the outcomes of the year. What could happen? What could happen?
Live or dead?
Yeah, either she lives or dies. But here's the thing. Living and dying are not numerical numbers. You need to figure out monetarily what does that mean for the insurance company and what are the probabilities of each of those. So that's what you need to find. You need to find these numbers here, right, and these numbers there. So I want you guys to talk to your neighbors and see if you can sort those out.
So, probability of it. Oh, yeah, 0.999. So this is 9. 7 minus 1. What is 9? Why does it even call it each? That's easy. So, here, 0, 0, 0.
if she dies, that's it.
Right, if she dies, they pay. Or if he dies. If this woman dies, then they pay. If she doesn't die, then they don't have to pay anything.
Oh, wow, look at that.
Oh, wait, the problem.
Right? Are you guys kind of following this idea?
Yes.
So what happens, what's the probability that so what happens if she lives, what's up with them? Do they get money or do they lose money?
They get
They get money.
They get money. How much do they get?
They get $360.
Sounds good? If she dies, then what happens?
They have to pay.
Then they have to pay. But don't forget, she gave them money, so how much do they have to pay? $100,000 or $10,000, $100,000, but they still get to keep the you pay in the beginning of the year, so they still get to keep the $360. So figure out, so those should give you those numbers there. Do you know the probability that she lives?
0.99.
Right, so then if you know the probability she lives, you'd be able to figure out the probability that she doesn't. So fill those in and find it. Okay, so the probability that if she lives, they get, what happens with them? They get 360. So I'm going to take out these guys here. They get plus 360. If she dies, what's up with that? Yeah, they lose 100,000, but they get 360. So really they lose negative, that's going to be negative 99,640. Right, they lose that much money. It's negative. What's probably that she lives?
0.999157.
Great. So the probability she doesn't is 1 minus that. 119, sorry. Okay. So then, oops, let me draw that better. So then you need to find your expected value. So your expected value of x is going to be 360 times 0.999057 plus negative 99,640 times 0.000943, and you will get, what will you guys get? Anyone? 265.70. Do you guys all get that, or are you guys still working on it?
Working on it.
Okay. Let's erase that.
Is that plus or negative?
Yeah, or you can do minus, right? You can do plus and negative, or you can just subtract it. Same thing. Is the minus easier? Should I just make it minus?
No, it's okay.
All right. Okay, so you should have 265.70. Good?
Yeah.
Okay.
What does that number represent?
Yeah. What? Okay. Do you guys need 30 seconds to confer with your neighbors? Okay, take 30 seconds, go ahead.
That's the mean. Expected. No, equals. So I can use it as divided. Why can't we do that? Oh, because it's like
All right, let's go ahead and move on. So now go back to page 2.
Page 2.
Page 2. So kind of towards the top, but not the very top of page 2, right? The variance. So remember, variance is sigma squared, the lowercase sigma. Sigma squared is the sum of every x value minus the mean squared multiplied by its weight, its probability. However, that is a giant bear. Why? Because the mean is nearly always going to be a decimal. So you take a whole number minus a decimal, you're going to get a decimal. You have a decimal, and then you square it. You're going to get some with more decimals. And then you multiply by probability. A probability is between 0 and 1. It's also a decimal. So now you're going to have lots and lots of small decimals. Do you see what I'm saying? And then you need to add them all up. It becomes a giant bear, and it's very difficult to kind of keep accurate. So instead, we use the computational formula, which you guys learned about last chapter, in chapter 3. And so you take every x value squared, multiply by its probability, add all those up, and then at the end, you subtract the mean squared. That's the variance. Standard deviation is the square root of the variance. Also, if you have this, and you want that, you take this and you square it, and you can get the variance. Right? The variance is the square of the standard deviation. It's the standard deviation squared. Right? It's this is that squared. If you just look at it, you can see it by symbol form. So first, let me show you an example of the alternate formula by hand. We had this example last class with rolling a dice. We found just the mean. Multiply every number by its weight, by its probability, add them up. And remember, we had the mean is 3.5. So here, we're going to take every number, multiply by its probability, square it, multiply by its probability, and then subtract the mean squared at the end. So this is going to be 1 squared times 1.6, plus 2 squared times 1/6, plus 3 squared times 1/6, plus 4 squared times 1/6, plus 5 squared times 1/6, and plus 6 squared times 1/6. Then we're going to subtract the mean squared, 3.5 squared. If you do this, you'll end up getting 1 squared is 1, so that's 1/6. 2 squared is 4, so 4/6. 3 squared is 9, 9/6. 4 squared is 16, 6. 5 squared is 25, 6. And then 6 squared is 36, 6. Minus 3.5 squared. Once you add up all those, you'll magically get the variance of 2.9. If you square root that, you get the standard deviation of 1.7. Now, because this has nothing to do with how you can't intuitively figure this out, right, from the definition of variance and everything else, then it's just plugging numbers into a formula. So instead, I am totally fine with, for this, you guys using the calculator functions to just find it for you, since it has no theoretical, logical background. So we're going to do that next. Okay, this is not, I repeat again, this is not your problem. So don't do it under your problem. Flip the page. See where it says lab problem 4? Don't do it there. Turn the page and do it up here where it says to do via calculator. That's where we are. So don't do it. This is not lab problem 4. This is a different problem. So write in 0, 1, 2, 3, 4 across the top. And if you want, you can write in 0.18, 0.34, 0.23, 0.21, and 0.04 along the bottom. What we're going to do is we're going to bust out our calculators. So everybody get out your calculators, your TI-83 or 84 calculators. Does anybody need one? Anyone? Everybody have one? Or if not, pull it up on your computer. I only have one. So is it on your computer? Yours is not helping?
I don't know what they're doing, I'm upset.
Oh, that's okay. Does anybody have, there's one computer over here that's messed up. So we're going to hop on over to our computers. And we're going to open up our TIA calculator. It's this little, remember it's the calculator with the little white bunny here? Rabbit Emu. Open it up. Turn it on. On is at the bottom left. And then we're going to go to Stat, Edit, Enter. Put your data. If you have stuff in here, you can hit Clear, Enter, and that will wipe it out. If you go up to the very, very top where you're on the L1, not here, but where you're actually on the L1, Clear, Enter, it'll clear it out. And you're going to input your data. So here's our data. 0, 1, 2, 3, 4 across the bottom. 0, 1, 2, 3, 4. And then arrow over, right arrow over to get to L2, and then put in the rest of the data there. 0.18, 0.34, 0.23. Yeah, you guys use this right here. This is great. Right, you just put it in and hit enter and it'll jump around. It's super easy for you. Very, very, very quick. No looking on with somebody else. You all have to do it yourselves. You have to have your own. So everybody should have that data up and in. Up and in.
Yeah.
I got SD, but I just put L1 and L2.
So you can set L1.
Yeah, don't do the one in your paper, do the one up here. So if you do the one in your paper, you're going to get the wrong answers. Do this one up here, these numbers. If you typed in the wrong number, you can just go back to it and just overwrite it. That's totally fine. Okay, then, so everybody has them in? We're going to go to Stat. So Stat, Calc, over to Calc. Austin, you got it? Over to Calc. We want 1 bar stats. We still only have one variable. We only have x. The other thing is the probability of x. It's not a whole new variable. It's just the probability that belongs to each of those x's. So you still only have one variable. So it's still 1 bar stats. Hit enter on that one. And if you have most of the 83s and most of the 84s, will give you this. If you have a fancy 84, you're going to get 3 different things. One will say list, and it'll say frequency, and then it'll say calculate. If you have list, frequency, so this one here, we want to put L1, comma L2 in it. If you have the fancy one, then you're going to put list is L1, frequency is L2, and then you're going to hit calculate. So how do you get L1? Do you guys see the little blue L1 down here in the bottom? I didn't hit the blue button to get that, so I hit the blue the second, and then I hit the 1, and then it pops in. You guys see it right there? The comma is right above the 7. The comma is above the 7. Second, L2. Enter. And it should give you that.
Nice.
Do you want me to do it again?
I got it.
Okay, I'm going to do it again. You guys be quiet and pay attention because if you didn't get it, then you're not going to get it again. Stat, calc, 1 bar stats, enter. Second L1, comma, right above the 7, second L2, enter. So your X bar should be your mean should be 1.59. Where's my variance? Everyone find the variance.
So you want to just put one alternate.
Find the variance. They don't give you the variance.
Oh,
What's variance? What's the symbol for variance? Sigma squared. There's no sigma squared here. Do you guys see that?
Yeah, no, it's zero.
So they don't give you the variance. Instead, they give you what? Sigma. They give you sigma. So you see where it says sigma x in the very bottom, the almost last one?
Yeah.
That's really sigma sub x. It means sigma of the x's. Because sometimes you have x's and y's, so they give you sigma of the x's, sigma of the y's. So it really means sigma of your x values. So your sigma is 1.123. Can you find your variance from there?
Yes.
Yeah. Because your variance is sigma squared, you just square it. Okay. Everybody all right with this part? Yes, no? Okay. So back to here. We ended up with our mean. So they call it x bar. I don't know why. It's really mu. Oh, because it doesn't know whether it's a, it assumes it's a sample, I guess. 1.6, 1.59. 1.6. And then my standard deviation is 1.1. Now, say this comes from this problem. Ashley, have you read yet?
No.
Go ahead.
A talk radio station has 4 telephone lines. If the host is not able to talk, i.e. during a commercial, or is talking to a person, the other callers are placed on hold. When all lines are in use, others who are trying to call in get a busy signal. Should the station have considered getting more phone lines instead?
Okay, so here's the deal. What was my mean? My mean was 1.6, and my standard deviation was 1.1. What our typical values are within how many standard deviations of the mean? 2. So if I have my mean of 1.6 and I go 2 standard deviations this way, I get to like negative something. Can't have negative color, so let's call it 0. I take my mean and I go 2 standard deviations this way, 1.6, I go 2 standard deviations this way, I get plus 1.1 plus 1.1, 3.8. Is everybody with me on that part? So this is 0 to 3.8 are my usual values. Usual values. Value, I can't spell that well. So if my usual values are between 0 and 3.8, do you think that I need more than that you need more than 4? No, 4 seems fine. Does everyone understand what we did? I have 1.6. I went 2 standard deviations this way, and 2 that way. I got negative 0.6 here, and I got 3.8 there. So these are my usual values. So now, I need you guys to do lab problem 4. Just use your calculator. Put them into lists and use your calculator. Lab problem 4.
On the test, will you tell us to use the calculator?